Hello, Barry. Hello again. Hello again, Malik and Ron. Hello, Chris. Malik does not have a camera or a microphone, so he's able to send us group chats, which is cool. We will appreciate everybody coming out on a Wednesday night to hear about uh, Electroair and electronic ignition system. Maybe we'll have some fun stories about aviation as well. Um, my name is Michael Kobelik. I'm one of the owners of Electroair with Daryl Poole. Collectively, we've got about 85 years of experience in general aviation. Joining us as well is John Shirk, who I've known personally for, well, I don't know, probably about 35 of those
Yeah,
40 years of
since I
time.
had hair.
Hair is
uh,
overrated.
well, we got everybody. Just Malik, I'm sorry you can't talk with us on over a microphone, but Ron introduced himself over the chat with he's got a Stinson 108 and an RV8. Did I see that correctly? Let me look. Oh, yeah. Yeah, Stinson 108 and an RV8. Chris and Barry, why don't you just jump in real quick? Tell us what kind of airplanes you've got or work on. Or not.
Sure. Hey guys, I'm Chris. I've got a Bonanza A36 and Barry does all the work on my plane, so thanks for inviting me.
Great. Glad you're here.
Barry, what kind of airplane do you have? Can't hear you.
Okay. How
There
about
you
now?
are.
Okay.
There you are.
Well, I fly the best airplane on earth. It's a Bonanza.
Yeah, but yours is a little different, isn't it?
Yeah, I've got a V-35 Bravo V-tail. I'll turn it around. You can see it there. 4163 Alpha. It's got a Lycoming 300 horse IO 540, and the airplane has every speed mod Mike Smith ever developed on it. Has air conditioning, just a great all-around traveling airplane. And I'm always been in the quest to make it go faster and faster and faster. So once you hit 174 true, every knot becomes very expensive to get. And so we're just trying to keep up with the Cirruses. We don't like them much, but we work on them. It's just a good battering back and forth between Cirrus and Bonanza owners. But anyway, that's what I fly, and we work on a lot of Bonanzas, and just recently put the Electroair on mine. Did a 3-hour cross country this last weekend, and all I can say is, wow, I'm just totally blown away by the difference in performance. So I
Hey
didn't get to
Barry, I
see.
think your mic cut out because I don't know about everybody else, but I'm not hearing you very well.
I can hear him.
Yeah, I also could hear
Okay.
him.
Okay. But anyway, very good performance improvement on fuel burn without a speed penalty going lean at peak. So very happy with that. So that's about it in a nutshell. I didn't get five knots like I was hoping, but
Well, so I had a conversation with Hartzell today. The engineers are looking at it for us.
oh, good,
I
good.
really do think we've hit the wall with the prop that you've got on there.
Yeah, it's
That
very,
is
very possible.
that is just not a very efficient blade design. And I mean, it was really cool back when Mach chose that prop, right? But
Yeah.
anymore, there's much better designs out there. So we'll see what they come up with. I threw a couple of suggestions at them. My girl is going to talk to engineering in the morning, uh, and I told her, I said, if you guys don't want to jump in the fray, give us a direction on how we can go about getting a field approval.
Yeah, yeah. That shouldn't be too hard.
Well, yeah.
You never know anymore.
Yeah.
All right. Let's get going then. By the way, I'll make a plug for Bonanza Parts. I used to own South Seas Ventures, which did a lot of Bonanza parts, now owned by McFarland. So want to save yourself a little money? That's a good way to go. Anyway, again, my name is Mike Koblick. I'm one of the owners with Daryl Poole of Electroair. We call this presentation Performance Through Technology. Electroair is a company, been around since 1992. We began life in the experimental aircraft world, putting high performance ignition systems on a wide range of experimentals, very easy, RVs, you name it. I often say we can do the widest variety of engines available in the experimental world because we've done them, both just about everything Lycoming and Continental you can imagine, Volkswagen engines and all 37,000 varieties of Volkswagen engines, Corvair engines, Jabiru engines, Subaru engines. We've run the gamut. Since that time, we've probably got about 7,000 systems out in the general aviation world, delivered and performing. During this presentation, if you guys want to text any questions, there will be a phone number down at the bottom of the slides for texting. Daryl will be the one grabbing the text and answering questions, or you can put it up in the chat and we'll try to answer them as they come up. Small groups, so feel free to interrupt me at any time. It's no harm, no foul in doing that. Actually makes the presentation for me and Daryl a lot more interesting if you do that, so please do it. A lot of our perception of what we expect from having an electronic ignition system comes from our experience within the automotive industry. The automotive industry, to address the need to get more performance out of engines, get better fuel economy, deal with the fact that they can no longer run leaded fuel, all of those sorts of things, started adding high performance or high energy rather ignition systems to their cars. And then later it came on electronic engine controls, controlling the engines with microprocessors and that sort of thing. High performance ignition systems need two things in order to meet the expectations that we have when we put an electronic ignition on an airplane. First, they need to have high energy, very high energy coils. That's necessary to be able to get the fuel air mixture completely ignited and going so that peak pressure occurs where we want it. The second thing they need to be able to have is variable timing. Variable timing accounts for, or allows us to account for, changes in atmospheric pressure. I'll often talk about why we have two ignition systems or two magnetos on airplanes in the first place. And the general answer I get is, well, we have to have two because of redundancy, right? That's actually not true. If you go back to the 1930s, where engine technology was beginning to explode in terms of, bigger engines, these incredibly large combustion chambers. If you think about the Rolls-Royce Merlin, it could develop 60 plus inches of manifold pressure. All of these things, we were still using magnetos from the 20s and 30s that had a relatively weak spark. So if you put just one spark plug in this great big combustion chamber and try to light that fuel air mixture off, the magneto didn't have enough oomph. So the engineering solution was, okay, we're going to make two, and we're going to divide the ignition job between two magnetos. Well, along in their infinite wisdom, the other thing I always follow, which is true, is, and I always ask people, do you know how a regulation begins life? And the short answer is it starts life as a good intention. So the regulatory body, the CAA at the time, looked at that and they said, hey, look at this, two ignition systems. We should require a primary ignition and a backup. And if you go back and look at the original Car 3 regs, if you can find them, I'm having a conversation earlier today, they're stripped off of the FAA website. The original reg on ignition systems said that you had to have a primary ignition and a backup. If you look now into Part 23, it says you have to have two ignition systems, period. Again, the original reason for it is we needed to have two magnetos to be able to light off that fuel air mixture and to get combustion event going, such that peak pressure occurred at about 16 degrees after top dead center.
Hey, Mike, before you,
Electroair.
hey, Mike, can you hear me?
Yeah, I can hear you. I thought somebody was asking a question.
Who was? I didn't mean to step on anybody. No, what
Oh,
I was
maybe it
going to
was,
say, while you're still at this slide, I want to kind of interject here. Being on the sales side of Electroair, I spend my day talking to operators, talking to shops, and probably the number one question I get is, how are we different from our competition? Um, and we all know who they are. It's Surefly and Lycoming. Lycoming is a relabeled Surefly. The difference is really in this slide right here. Those units are what we consider a battery powered magneto, whereas the Electroair system is a combination of a very large coil that can produce a lot of voltage. And as importantly, not just a lot of voltage, but we can hold that voltage out at the electrode of the spark plug a heck of a lot longer. Um, um, uh, Battery powered mag or magneto, Mike, what is it, about 3 degrees of crank rotation on that spark duration? 3 to 5?
yeah, as a matter of fact, at Oshkosh this past year, the slick engineer told me that they put out about 37 millijoules of energy, which is on a good day, maybe about 10,000 volts of energy through about 3 degrees of crank rotation. Pretty small.
Whereas we are what, 9 joules through 20 degrees of crank rotation?
We put out 9 joules of energy. And to translate that, that's 70,000 volts through about 20 degrees of crank rotation. We've actually measured it on the bench at about 78,000 volts through that 20 degrees of crank rotation. It's
Well,
just a really big spark.
yeah, and for you guys that
As
don't know
often
it,
as
for you
as
guys,
often as not, I call
go
it the
ahead.
sledgehammer approach to ignition systems.
For you guys that don't know it, I've had to learn all this stuff from Mike. By trade, I'm actually a prop guy. I spent 35 years overhauling aircraft propellers. And Mike, I was listening to one of his presentations at Oshkosh, and he was talking about this particular slide, and it finally hit home with me of what's really going on with our ignition system. And he explained it this way. If you think about what happens when the intake valve opens on these engines, fuel and air is being sucked into the cylinder, and that fuel and air is spinning like a tornado, so tornadic activity. So when the spark plug starts firing, the fuel and air that's passing through the electrodes and in close proximity to the electrodes, that's what's being ignited by the ignition event. So the longer that that spark is taking place, the more that fuel air you're going to get ignited by the ignition event. Therefore, you've got more of it already ignited. It's going to propagate faster throughout the cylinder and complete the burn of the fuel air mixture and use it for work, as opposed to traditional mags or even battery powered magnetos. It just can't get it done, especially at altitude. There's just not enough energy. There's not enough spark duration to get all that fuel and air burning at a very quick rate and consumed, so that we build peak pressure and have that fall at the right time, which is right around 16 degrees after top dead center. This is really the meat and potatoes of how we're different. Granted, we're a totally different looking system. We are truly a system being defined as multiple components tied together to create a whole. We're not just a drop-in replacement mag. And the end results are completely different. Really been wanting to get that cleared up out there in the industry, that we are not a drop-in replacement mag. We are a true high energy, high performance electronic ignition system, because we combine high energy, long spark duration with very accurate computer controlled timing. You got anything to add to that, Mike?
Couldn't have said it better myself.
It's because you did. And I remember. Press on.
So the idea behind all of this is when you're doing this, and I'm sorry for the Bonanza guys, this was the picture I had. You can see this. Fuel savings. In a 6-cylinder engine, we typically see 1.5 gallons to 2 gallons per hour. 6-cylinder normally aspirated engine. If we're turbocharged, fuel savings probably closer to 1 gallon per hour. Typically, we see airspeed increases. Now, this is not true on every aircraft. We got to qualify that. You have to have an airplane that's slippery enough already to see some airspeed increases. For example, a Bonanza, it's very common if we leave the fuel in. We've had plenty of reports of guys going faster, about 5 to 7 knots faster. Cessna 185, to pick on that airplane, it's not designed to be slippery. It's designed to be a truck. So the airspeed increases are probably not as significant, but the fuel savings are right there as well. And for those of us getting up there closer to our retirement, we get better ramp appeal. We might be able to take 20 years off your ramp look. Good. I'm glad I heard some chuckling about that joke.
Can I get a refund? I didn't get my 5 knots, Mike. I want my 5 knots.
I'm working on that.
Did you go back and put the fuel? So Barry put the system on dual systems on his Bonanza.
No, he's got single.
Single.
Oh, it's a single system. I'm sorry.
Yeah.
You did see 1.6 gallons per hour fuel savings.
I definitely got that. I would say closer to 2. Yeah. At altitude. Now I was up at 15.5, so.
When you go back, I'd like to see what speed you get if you leave the fuel in.
Yeah, that's going to be my next test. I'll go out and do my same triangle test, and I'll report how we do. It might do it. Yeah, we'll see.
So you can typically see this lower EGTs, lower TITs, reduced exhaust valve wear. Why is that?
No lead on.
Lower EGTs. The better job you do burning the fuel air inside of the combustion chamber, the less burning plasma is going across the exhaust valves. If you have an airplane that has the ability to put a power flow exhaust system on there, the savings get even better. A tuned exhaust system is designed to evacuate the combustion chamber quicker and really take the back pressure off of the engine. If you're running 2 magnetos and you're pulling off the combustion gases faster, there's a very high probability you're pulling off burning plasma across the valve seats. One of our installation centers did a study on Grumman Tigers where they had 3 aircraft. They had one that was set up conventionally, 2 magnetos, factory exhaust, one set up 2 magnetos, power flow exhaust, and then the other one set up with an Electroair system, power flow exhaust. They measured over, Daryl, how long was it measured? It was about a year, I thought, wasn't it?
1,000 hours.
Anyway, the control airplane, the exhaust valve wear was measured, and that's your baseline. The airplane that had the 2 magnetos and the power flow exhaust, that saw about I'm going to say, and Daryl, correct me if I'm wrong here, about a 20% increase in exhaust valve wear. And again, because the exhaust is burning plasma across the valve seats.
It was actually closer to double.
Is actually closer to what?
Double.
The exhaust. Double the exhaust. So the aircraft with 2 magnetos and a power flow exhaust had twice as much exhaust valve wear as the airplane that was just 2 mags and a conventional exhaust. The third airplane with the power flow exhaust and the Electroair system, the exhaust valve wear was less than the conventional airplane with 2 mags and factory exhaust. I don't remember the exact percentage, but it was significant enough to be measured. Better combustion equals less blow-by. Blow-by is the byproduct of combustion, and if it doesn't go out the tailpipe, it creeps past the rings and ends up in the oil, contaminates the oil. Large reason why we have to change oil every 25 hours if you don't have a filter, 50 hours if you have a filter. Better leaning at high altitude. That's a direct result of not only the variable timing, but the high energy coming out of the coils. At altitude, you've got this massively big spark that's not being degraded by going through a distributor and is able to light a very lean fuel air mixture, the leaner you go. High altitude misses are also gone. John, in fact, had mentioned earlier today, he's got a couple of customers that are concerned about this. What happens in a magneto at high altitude, as the air gets thinner, there's less resistance inside of the distributor of the mag. And so as the wiper is moving around the distributor, energy is going to go find its path to ground. It's going to take the least resistant path to ground. Without the air inside of the distributor, now the spark might jump around, and that's going to cause a miss. And you'll feel it at high altitude. There's no distributor in our system. The spark energy goes directly to the spark plugs themselves. Reduce maintenance. There's virtually nothing that you need to do other than plug wires that we'd like to see you do every 1,000 hours or 5 years in service. The mag timing housings, regardless of whether it's a 4-cylinder or 6-cylinder, they're both rated in the ICAs out to 2,000 hours plus. I've got an operator at our local airport that has them on archers in a flight school. They're running these mag timing housings out 4,000, 4,500 hours before they change them. I mean, when they bring them back in, they look like they've been through the war, but 4,000, 4,500 hours without having to touch an ignition system component's pretty good. And we all know that magneto overhauls and such are becoming more and more expensive. High energy, variably timed ignition unleashes the power that's in your engine. But providing the tuned ignition system for your engine, you're going to get closer to the rated horsepower that's actually placarded on the engine. I get asked this question periodically. Daryl probably gets it more than I do, but how much horsepower does the Electroair system add to my engine? We have to be very careful there. The lawyers would go nuts over the wrong answer to that. We are not increasing the horsepower, the rated horsepower of your engine. In other words, we're not taking a 300 horsepower engine and turning it into 310 horsepower. What we are doing is taking the actual horsepower output and moving it closer up to that rated number. And all those engine placards, that rated horsepower is the result of a very elaborate math calculation. As you start adding components onto these engines, a magneto, for example, typically draws off about a 1 to 1.5 horsepower off of the engine. So simply by getting rid of the magneto and putting a trigger mechanism that has no load, you bump the horsepower up by 1.5 horsepower thereabouts. Anytime you're able to remove weak systems off of the airplane, you're going to get increased horsepower and get it closer to what it's supposed to be. Here's a picture of our 6-cylinder dual mag replacement. We have systems available for 4-cylinder and 6-cylinder, single systems, dual systems. We've been approved since 2011. Dual systems were approved in 2022. As I mentioned, we sell these systems as well into the experimental aircraft world as well. It was Ron, I think, who had the Stinson 108. Depending on what engine you've got, we've got, I think the 108 is the 4-cylinder engine. We've even done them on 4-cylinder Franklins. Certainly on the IO390 conversions that I know are out there for the Stinsons. And then, of course, the experimental stuff, no problem.
Mike, Ron's
15% gain in fuel economy, increased in many airspeeds, better hot starts, shorter takeoff runs, the ability to leap tall buildings in a single bound, you name it.
Go ahead, Barry.
Ron texted it up on the screen. He's got a 540 in his 108, like coming with the dual mag.
Really?
Holy crap. Wow.
4-cylinder Bennett single drive dual mag replacement, again, 2 kits. Both of the dual mag replacement kits that we put together, we actually separate both ignitions from each other. So there are no common parts between the ignitions. And therefore, you're not going to have catastrophic failures, for example, if you lose an impulse coupler. Catastrophic failure if you have the distributor come loose inside of the unit. We had one not that long ago that I saw a report on. Magneto had just been serviced in I think it was a 182 RG. They depart, pilot and passenger. The whole cap of the magneto came off. Or I'm sorry, the whole magneto came away from the engine, decoupled from the engine quit. They were at about 300 feet over trees. Not a pretty sight, unfortunately. Very popular one. Again, it's nice to have a couple Bonanza guys in here. This is the kit for the 6-cylinder Continental engines, single kit. get asked all the time, should we do single kits versus single ignitions versus dual ignition systems? The guys with the Bendix dual mag, you're stuck. We got to do dual ignition systems. There's no two ways around it. But for most of you, a single Electroair system is going to be sufficient to take care of what your expectations are. I always use the scale. If we look at a magneto being at 0 and a dual Electroair systems being at 100, with the first Electroair system, you get about 85% of the way there, 85, 90% of the way there. You get what I call the wow factor, the big pickup in fuel economy, the smoother running engine, the easier hot starts, the shorter takeoff runs, increased airspeed, all of that. The second ignition system, the second Electroair system, will help at high altitude operations. High altitude meaning 15,000 feet and above. The truth of the matter is most of us in GA don't go that high. Things just get different up there, easier to not carry oxygen. Here are some of the Electroair powered aircraft, recent ones that we've had systems put on. And with that, what questions do you guys have? How can we help? Daryl's got his order pad ready to go.
What would be your expected downtime if someone takes their airplane into a shop to have the system put in? How many days or of downtime would you expect?
Man, John, that's a loaded question. So how
how
long do we expect the installation to go? The short answer is it depends. What we've always told customers, if you're looking at, say, a 4-cylinder application, expect 2 days in the shop. The first day for sure, the second day to catch all the things that you didn't expect. For a 6-cylinder application, I would add a day to that. 2 days for sure, and then the third day to catch the things that you didn't know you were going to catch. So we're looking at, and then when you go to dual systems, it's even a little bit more. I really try to stay away from committing to too many hours or getting a quote on that. Give it more of a guideline to the customers, and really emphasize to both the owners and to the shops. This is a great opportunity to talk with the owner of the airplane, make an installation plan. As Daryl mentioned, as you've seen in the pictures, this system is different from a magneto, right? It doesn't look like a magneto. And you've got to think through where the parts are going to be. The installation manual is written in such a way that it gives the shop the flexibility to install this on the airplane that they're facing and not the airplane that I think it is. Wise old man called me up from Pontiac Airport one time, Johnny Johns. John Shirk will remember him. Anyway, he calls me up. He was having his guys install the system on his 206. And he says to me, Mike, I hate your installation manual and I love your installation manual. I love your installation manual because it lets me put the parts where they need to be on the airplane based on how modified the airplane's been over the last 40 some odd years. I hate your installation manual because the two technicians working for me, I just caught them spending an hour debating about where to put the coil. This is another thing that we tell shops and maintainers all the time. Do not unlearn the things that you already know. This is just an electronic ignition system. It's not magic. It's not voodoo. You're not having to learn a new language or anything like that. And approach it sensibly, ask good questions, and get the parts installed. We've had a couple of questions come through on the chat. Brent asked, what are the expected fuel savings on an IO360 single system? About 1 gallon per hour. That's real consistent on a 4-cylinder Lycoming engine. Daryl, Ron just texted you a question. He has from Ron, and I think we have already answered this, does the Electroair system remove the single point of failure of the Bendix dual mag? Yes, all of them. Removes. There are several there are several single point failures on a Bendix single drive dual mag. I mentioned two of them: the impulse coupler, the distributor. Depending on the age of the dual mag, if it's a D2000, the case that holds the whole unit, that holds essentially the guts of the magneto, are real prone to cracking around the bosses of where the screws that hold the cap on go in. That was one of the big improvements that they made from the D2000 to the D3000, was they beefed up those bosses where the screws go in to help prevent cracking. In fact, when I had the parts business, one of the first things we looked at when we got a dual mag in is you looked at all of those bosses to make sure they weren't cracked. If they were, the core was junk. They just threw it out.
Hey, Mike.
Yeah, go ahead, Daryl.
One of the things that we need to talk about when talking about these dual systems, whether it be replacing a Bendix single drive dual magneto, or and I've got several customers that have done it. They're just tired of magnetos and they've replaced both magnetos, even though they were two separate magnetos. Anytime you go dual, since our systems don't produce their own power, we've got to back up the electricity somehow. The most common way that we're doing it is with the TCW Technologies lithium iron phosphate backup battery system. That's the only battery system currently approved for use with dual Electroair systems. The other option is a standby alternator, the most common being the BNC Specialty standby alternator. The standby alternators are going to get wired a little bit differently. Normally they're wired so that if the logic senses a drop in voltage, a field is sent to the alternator and it starts charging. When you use it to back up electronic ignition, it has to be charging all the time. You have to have the ability to reach up there and cut the master off and still have power to at least one of the ignition systems. So it does get wired differently, and it's a more expensive option. The cool thing, or the nice thing about going with a standby alternator, is that standby alternator is treated the same way the main alternator is treated as far as load. You can put up to 80% of capacity on it. So you've got some excess power that you can use to power some other systems on the airplane. Whereas going with the backup battery, and the FAA really dug their heels in the sand on this, you can only put one of the ignition systems on the backup battery. And actually, I guess in hindsight, it's not a bad idea. Their worry was that people were not going to do proper calculations on loads, and they were going to overload the battery. And now we don't have enough to run the ignition. I mean, it is what it is. The folks at TCW, which for those that don't know, that company sold to Jeff Kelly, former Kelly Aerospace. They're still putting out it's still a great product. They went a little bit up on price, but they have told me that they are working on, and not just for us, it's for the other guys out there too, working on a less expensive version of the battery, because the battery that we're using is really overkill for what we're trying to accomplish. For example, in the 12-volt world, we've got two options: a 3 amp hour or a 6 amp hour. A 3 amp hour battery will run a single 6-cylinder system for over 2 hours. The FAA requirement was an hour. We had to be able to keep the airplane running for at least an hour. And of course, you got to remember, the only time that backup battery is going to come into play is you got to lose the alternator. And then the main battery's got to completely drain to below 8 volts, and that's going to kick our system out. Actually, prior to that happening, the logic in the battery is going to see it, and it's going to take over that one system. And then the other system that's on the main electrical is going to eventually drop off. And that's the reason for our battery condition panel. Your battery condition panel has a voltmeter in it so that you can check the condition of the battery prior to flight, during flight. It's also got LED lighting in it, 2 green lights and an amber light. The 2 green lights tells you both systems are up and functioning properly. If one of them goes off, you've lost a system for some reason. If the amber light comes on, that tells you that, hey, you're on the backup battery. Uh, Time to make some decisions. And
If you have,
go ahead, Chris.
if you just have a single system, that's run off the main ship battery then? Is that what I'm
Yes.
understanding?
Yes. Single system, you're not required. Your backup really is the remaining magneto.
Right.
Because it really, if you lose the Electroair system for some reason, it really be no different than losing a mag in flight, which happens more often than I care to admit. I've had 3 people since I started selling Electroair and prior to buying Apple Electroair that lost magnetos in flight, had single Electroair systems, lost the mag in flight, and didn't know it till they went to fly the airplane again because there was no change in performance. Had they been staring at the EGT when it happened, they would have seen it. They all went back and looked at their engine data and they could see exactly when it happened. Just an ever so slight increase in EGT when that mag dropped offline. And that, in hindsight, that's really why the FAA was adamant about this battery condition panel. And ironically, our competitors didn't have to have it, but that's neither here nor there. And I guess now I understand why. With our systems, they're so powerful, and we've already had this happen. I'll let Mike tell that story. If you lose a system, your chances are you're not going to know it. You're not going to see a change in performance. A single system can run these airplanes just fine. They're that powerful. Mike, you want to tell the Patriot parachute team story?
Yeah, I want to come to that in a minute. I want to make sure we answer. Brent chatted in a couple of questions, which are really good questions. First one is, are increased CHTs to be expected, and if so, by how much? And then the second question, are there any operational considerations to be aware of? Let's talk about the CHTs first. And Daryl has a little bit of a slightly different take, in particular because he owns part of an aero club, and he's got a lot more hard quantitative data than I might have on it. My view has always been, and what I've always told people is, yes, you should expect a slight increase in CHT. 20 to 30 degrees is pretty typical. Sort of depends, though. There's a lot of installations where we haven't seen any increase in CHTs. If you see an increase of CHTs that are more than that 30 degrees, say it gets on the order of 40 to 50 degrees, that means something's not right. Most likely the timing, and more specifically, most likely the mag timing housing or the trigger wheel isn't set correctly per the installation manual. You see that, get on the horn with us, and we'll walk you through the troubleshooting steps to get that corrected. So 20 to 30 is typical. Lots of installations, we haven't seen any at all. If you get beyond that 30, so you get into the 40 to 50 range of increased CHTs, call us and we'll walk you through some of the troubleshooting steps. A lot of things, one of the topics that we haven't really touched upon, and this goes a little bit into the operational consideration question that Brent's got, is we have found time and time again, when you put an Electroair system on the airplane, you're removing what I consider to be the weakest link of the whole propulsion system of the aircraft, and that's one of the magnetos. When you remove the weak link of any system, what you do is you expose the next weak link. And we have discovered, I've lost track of how many engines that we found underlying engine problems that were masked over by having a magneto system. Induction leaks is probably the biggest one that we see. Fuel system setups not done correctly. I just reviewed one on a mall where the fuel injectors, he's got 2 fuel injectors that are just not operating correctly. It wasn't there before. What other maintenance issues am I should be talking about, Daryl?
You were talking about the increase in CHT. One of the bigger ones that I often see is baffling. And just
Baffling, yeah, for sure.
torn up baffling, holes that weren't properly sealed. These are air-cooled engines, and baffling is extremely important. It needs to be tucked the correct way. we need to be forcing that air over those cylinders. I guess the other big thing, and I'm an old prop guy, and I've had to learn a lot about engines over the past 10 years, and I've had some great mentors, Mike being one of them. Another one is one of my favorite gentlemen, Bob Menace. He's a former Continental engine engineer. He actually led the design team on the top flow induction 550s, which is a phenomenal engine. Anyway, Bob and I were sitting at Oshkosh one year, and I asked him. I was still pretty green with Electroair and ignition and engines, and I've been a lot of people have been asking me questions about cylinder head temperatures, and I asked Bob. I said, what do you consider to be the optimal cylinder head temperature? And you got to remember, Bob's got a lot of STCs. He's done a lot of flying. And he told me, and I confirmed this with some other engineers later on in life, 375 to 390 is his sweet spot. 400 degrees and climb out doesn't bother him. He doesn't want to see it constantly over 400 when you're in cruise at altitude. That indicates something's probably wrong. Conversely, he said, and I started seeing this myself, you got these guys that think they want to keep their CHTs down around 300 degrees. And that's absolutely wrong. At those lower temperatures, instead of the exhaust gases staying in a gaseous state and evacuating out of the cylinder, you've got a high chance that it's cool enough that they're actually going to solidify and attach themselves somewhere in the cylinder. And it's typically around the valves. So he said, if you keep those temperatures up in that 375 range, everything stays in a gaseous state and is going to evacuate the cylinder pretty well. I guess that's about all I've got on that, Mike, as far as the CHT question. To address the other topic that you talked about, the ignition being the weak link. I mean, that we literally probably deal with that at least once a week. And as the sales guy, I have to have this conversation ahead of time with customers, because we all want to believe that our airplanes are perfect. And I know mine aren't. They're close because they're heavily maintained and they're flown every day. But it's little things, just that magnetos just ignore. And probably the most common, Mike already mentioned, is induction leaks. And we've literally, just in this past month, we've had 2 freshly overhauled Lycoming 540 engines, freshly overhauled. One of them had 5 out of the 6 induction tubes leaking, and the other one had, I think, 3. These are freshly overhauled engines. Well, these shops, it didn't used to be a big deal because magnetos are so weak that they're not doing a great job of combusting that fuel air mixture. Whereas you put a high energy ignition system on there like ours, it's going to burn it. And if it's uneven, you're going to feel it. You're going to notice it. You're going to see it on your engine monitor. So that's been an issue here lately. Induction leaks have been crazy. I mean, I guess to address the whole thing, the problems that we see, probably 99% of the time are either related to an existing engine problem that was already there, that has gone unnoticed. And the second big one is poor installations, which is why we try our best to go out and gather the best shops across the country to do these installations under our recognized umbrella. And we've been pretty successful with that. We're super excited about Barry and his crew coming on board. We've seen pictures of their work. They do a great job. We've had to let some install centers go over the years that just were not performing up to our expectations. I'm an anal asshole. I'm not going to lie. Mike knows it. When it comes to airplanes, to me, there is no room for error. I think it was last year, the year before, I was on Beach Talk, and there was some guys bitching about my old propeller shop here in Houston. Man, you take it over to those guys, they're going to scrap everything in your prop. Well, if it's a piece of shit, yeah. If it's been hanging out there on the crankshaft for 20 years and you haven't paid attention to it, and you bring it into me and I've got a set of regulations and manuals I got to go by, if it doesn't meet it, it doesn't meet it. I'm sorry. And I'm very proud to say in my 35-year prop career, Not one airplane went down because of the work we did. Not one. Never had an issue. Zero. And there's reasons for that because we're professionals about what we did. Little more history. That particular shop, the folks that bought it from me sold it at the end of 24 to Hartzell. Hartzell now owns the shop here in Houston that I used to own. It's now called Texas Aircraft Propeller and Accessory. Still an excellent shop, and Hartzell's only buying the best shops out there. Kind of went off on a tangent there. Sorry about that. I'll turn it back over to you, Mike.
Thank you, Daryl. Other operational considerations, as I've been sitting here thinking about it, the one thing you will notice is a difference in the ignition checks pre-takeoff. We're very used to checking the ignitions when they're two magnetos and seeing the same drop between both. We have to remember we're looking at two things when we do an ignition check. When it's a two magneto airplane, we're looking to see to make sure the magnetos are both working. That's the first thing, obviously, right? But the second thing is to look at the delta or the difference between the RPM drops. If you exceed a certain RPM delta, then that's telling you one of the magnetos is got probably a problem. It's either off by timing, or if it's running rough during that same time, you've got a bad plug, bad lead, something going on inside of the magneto. When you have an Electroair system installed with a magneto, you do the ignition check, drop off the electronic ignition. You'll see the traditional RPM drop when you're on a single magneto, 100 RPM, 75 to 100 RPM. Actually might be a little higher now because the amount of fuel it takes to get to your run-up RPM is less. So when you shut off the Electroair system, you might see a little bit slightly higher RPM drop. That's okay. Go back to both, turn off the magneto. You should see no more than about 30 to 35 RPM drop. And that's regardless of whether it's a 4-cylinder or 6-cylinder. Many of these applications, when you shut the magneto off, you don't see any RPM drop at all when you're on the Electroair system.
What did you see, Barry?
Higher than that RPM drop, and the drop is smooth, that tells us that the timing is off in the electronic ignition. Probably at the mag timing housing or the trigger mechanism wasn't set correctly. Again, if you see now a big RPM drop and you've got a rough running engine, 95% of the time that points to a bad plug or a bad wire. And that obviously needs to be addressed. So those are the only other operational considerations. There are no in-between inspections of the components or anything like that. There's no 500-hour requirement. I had mentioned earlier about the ICA calls for, recommends that the spark plug wires be changed every 1,000 hours or 5 years in service. The reason for that is simple. We use a high-performance race car wire that has a silicone outer jacket. That silicone outer jacket over time will weather check and will crack, and you can start to have energy leaking through the jacket, arcing. That'll cause a rough running engine. It's a precautionary thing in the ICAs. The other components, the mag timing housing, as I mentioned, are time limited. Again, per the ICA. I wish more people would follow them because they are really good recommendations. As a manufacturer, we don't create instructions for continued airworthiness just for the sake of it or the heck of it to sell parts or things like that. Those ICAs, those recommendations are based on a collective amount of history within the company is how we arrive at them. Other than that, that's it. I mean, as far as operational considerations. Brent asked another question. After the installation of a single system, would there be any benefit to getting his GAMI injectors recalibrated, tuned to take advantage of the increased spark? I'm going to say no, because the whole purpose of the GAMI injectors is to tune the fuel injectors to match the intake system of the aircraft. If we think about the Bonanzas with the bottom induction system, the amount of air that's coming into the back cylinders is different than the amount of air coming into the front cylinders. And accordingly, because the induction air is being heated as it's traveling up to the front cylinders. So you change the fuel injectors to match the differences in the induction system. If you're now running a 550 with a top flow induction system, a tuned induction system, those injectors look different here again as well, because the amount of air that's now coming in is more balanced and evenly matched from the back to the front of the engine, and the adjustments needed in the injectors really, I'm out of my lane, but you don't need to make as big of an adjustment to those injectors, I would think, as you would with the bottom flow induction system. The spark, as far as the combustion event goes, again, I mentioned this before. We take a sledgehammer approach to spark. We put a big, fat, long duration spark there to ignite the fuel air mixture that's coming in. We don't touch the fuel system or the fuel air mixture at all. So the mixture components of it are dictated by the injectors and by the induction system, not necessarily by the ignition system. And Daryl, you wanted me to tell the story about the Lance, right?
Yeah.
So we work with a group of guys called the Patriot Parachute Team. They are returning warriors, frankly. They're comprised of a lot of Navy SEALs, a lot of Air Force pararescue people, Delta Force guys, all kinds of guys that have gone overseas, served, and are coming home. Now, a lot of the purpose of the Patriot Parachute Team was to give these returning warriors a place to go where they could decompress, but then also go do some of the crazy stuff that they were used to doing in the service and get their adrenaline rush. They jump out of Piper Lances across the country, and they're the ones, one of the teams that do all the crazy jumping where they join together by their feet, they're spinning around, and they're doing all kinds of fun stuff. Great group of guys. Well, anyway, we worked with them on their first Piper Lance, which had a Bendix single drive dual magneto. And they noticed a lot of changes after they replaced it. First of all, they had a radio noise problem in their dual mag that they couldn't identify until they got rid of it and put the system on. The radio noise went away. The other thing that they noticed is that and Isaiah, the guy who owns the Patriot Parachute Team, he is just a statistic junkie. I mean, they measure and record everything you can possibly imagine on that airplane. They picked up on a Lance, if you can believe this, 10 knots, and translated, they're able to go around the planet one more time on a single engine overhaul, because the increase in airspeed reduces the amount of time they're in the air, et cetera, et cetera, et cetera. Well, anyway, they had our backup battery system on the airplane. They had some avionics work done. And when the avionics work was done, the alternator outlet was not reinstalled on the panel. They also installed an EarthX battery, which is a really kick-ass battery. I am very impressed with that unit. Anyway, they had a trip to take. Pilot comes into the airport, picks up the Lance, takes off, flies it to his home airport to spend the night, gets up the following morning, launches off, and all of a sudden he's going, and everything goes dark on the panel except for the amber light on the backup battery panel. The only way he knew that he had a complete electrical system failure. The engine never missed a beat. It kept running, and he was able to make a landing, albeit when he cranked down the landing gear, he wasn't able to get it all the way locked, and one of the gears folded on him when he landed the airplane. But when they tracked back through the data, they saw where the alternator had failed on 3 flights prior. So the alternator failed. They were running off of the EarthX battery. They took off, count the trips here. They took off, cycled the landing gear up. They transitioned the airplane from the airplane's home base to the pilot's home base. He lands, which requires another extension of the landing gear. Gets up the next morning, starts the airplane, takes off, retracts the landing gear, and that final retraction is what wiped out the EarthX battery. The way he knew that he had a problem is with the amber light on the backup battery panel. Pretty impressive. impressive story really about the Earthex, but also the smoothness at which there was no hiccup. I mean, everything worked. The backup battery panel or the backup battery itself came in place. Ignitions never missed a beat, and the engine continued to run just fine. Ron sent over a question about with the push to eliminate 100 low lead and switch to unleaded fuel, are there any drawbacks or any benefits or drawbacks with switching to Electroair?
I'm
Short
out.
answer, no,
I'm out.
absolutely not. In fact, there's probably some real benefits to switching to Electroair now because, well, first of all, our STC has no fuel limitation on it whatsoever. The SureFly system, I think, still has 100 low lead fuel limitation on it. So I'm not sure how well that's going to work with unleaded fuel. The Lycoming one would have the same limitations to it. Secondly, it's been my contention, and I get on my soapbox about this, that one of the things that I think we failed to learn in general aviation was what our automotive brethren did back in the 80s, is that they had to introduce high-energy electronic ignition systems when we went away from leaded fuel, so that we could get the performance out of it, get the fuel economy standards we needed back then. All of those things were in play. So, yeah, I think that electronic ignition system, a high-energy electronic ignition system, particularly for the high-performance airplanes, are going to be a necessary thing as we move forward. And we are working with different players within the FAA, outside of the FAA, to evaluate those very questions. Daryl, you want to add anything into that?
I wish I could, but we're not supposed to yet.
Yeah, we really can't.
Hey, I need to drop off here in 2 minutes, but I just have a couple of questions. One is there any notable weight increase to be aware of? And number two is, are they compatible or STC'd with the like a Tornado Alley turbo normalizer system? I've always been considering adding the turbo normalizer later. Would that cause a problem here?
Let's answer the weight one first. On your Bonanza, there might be a small weight penalty because of the size of the coils. But having said that, you're pulling weight off of the engine and putting it back closer to CG. So you're not going to notice it from a change in weight and balance or anything like that. You'll still have to do one when you put the system on, but it's pretty straightforward. And the weight difference we're talking about is 16 ounces, maybe. I got to be honest, I haven't weighed a Continental mag in a while, so. But that's the range that we're talking about. As far as STC compatibility, we have no limitations with working with other STC components that are out there. That's actually part of the certification process, is you have to go through and as best you can. I mean, it's impossible to go look at all of them, but look at the STCs that you might have that might interact with your STC, and there's no issue working with the GAMI turbo normalized system. One thing that we do if you were to go with dual systems on a turbocharged engine or on a GAMI turbo normalized engine, anything like that, is we probably will back the timing off by at least a degree. That increases the detonation margins. We've had several discussions with the guys down at Tornado Alley about that, and that's the most sensible approach, is when you get a situation like that, if you're using dual Electroair systems, and Chris, on your particular airplane, I don't think you need to, but we're certainly not going to stop you if that's the direction you want to go. We would just back the timing off and either flatten or remove the advance curve based on manifold pressure.
Thanks, guys. I appreciate the time. I'm going to have to drop off.
Chris, thanks a lot for coming. Appreciate you
Chris,
being here.
appreciate it.
Hey, Chris.
Ron asked a question, is our STC tied to the engine or airframe, since my airplane since his airplane has an STC'd engine to the airframe, would that be an issue? So Ron, there are two STCs. There's an airframe STC and there is an engine STC. On the originally, believe it or not, we were just an airframe STC. Traditionally, you have two with a system like this, but our original STC, our FAA engineer was a little bit of a radical, and he said we don't need to have two STCs. One's just fine. After he retired, the FAA came in their infinite wisdom and said, we're going to give you an administrative STC for the engines. This should only take 90 days for us to do, and 8 months later we got the STC. So not atypical. Specifically to your Stinson 108, I'd have to look at the AML to see if they're listed. If they're not, if it's not, I should say, probably would have to do a field approval. Fairly straightforward to do that because you use the existing STC as the approved data to have it installed on your airplane. I know on another Stinson where an IO390 was installed, he had to do a field approval for the 390, and he wrapped in the field approval for the electronic ignition on the same one. We do have a resource that's become available to us, a retired FAA manager from the Detroit FSDO. As a retirement gift, they gave him all 58 function codes for acting as a DAR. And he works with people all the time doing field approvals on a variety of things. Rick is very reasonably priced. Paperwork's all done. You basically submit it and you're done. There really shouldn't be anything after that once the paperwork's completed and submitted. Any other questions, comments, thoughts? Again, Daryl's got his order pad ready to go.
The Stinson 108 is not in our AML. I didn't think it would be. That originally had a Franklin engine in it, didn't it?
Yes.
Yeah, I think most of them were that way from the factory. Yep.
Yeah. So it would have to be a field approval. Which, like Mike said, it's with Rick, it's no big deal. Hey Barry.
Yeah, I originally had a Franklin 165, Ron said.
Hey Barry.
Yeah. Go ahead.
We cut you off a while ago. I was curious to know what your RPM drop was just on the Electroair system alone.
Yeah, so the two that we've installed recently, one was a 4-cylinder Lycoming in a Citabria. I pushed it outside, started it up, and let it warm up everything. And I did a mag check, and the mag when I turned the Electroair off, it dropped 180, 200 RPM, and I was like, whoa, something's going on. So it ran great on the Electroair, no problem at all. Pushed it back in, and I'm like, well, I guess I'll start looking at the engine, and the thing's, I don't know, 20 hours since annual. And out of the 4 spark plugs that were running the mag, 3 of the 4 were fouled with lead. So they were, bottom spark plugs, of course, and 2 of them were. And so we cleaned the plugs and, checked the timing. We checked the timing when we did the install anyway, but pushed it back outside, and the drop was about 100, 110. And that seemed normal. We flew the airplane, no appreciable change in CHTs. Everything ran great, test flight. My airplane, I'm seeing about 80, 85 on the RPM drop on when I'm checking the mag. The mag that's in there's got about 480 hours on it. Original wires to the mag, so it's got some time on it. When you turn off the mag, the RPM doesn't even move, and it's really kind of spooky because you're so used to flying an airplane with you're used to seeing 40 to 80 drop each time. When you kill that mag, it just sits there and purrs like a kitten on it, and you can feel in the seat of your pants when it's running on the Electroair versus the mag. It's just a night and day difference. So But yeah,
Nice.
I've been seeing a higher RPM drop when you go from the when you turn that Electroair off. It is higher than normal, and it took me a little while to get used to that, but that is normal from my understanding. And Mike can correct me if I'm wrong, but yeah, that's what I'm seeing.
Perfect. Perfect. That means you did a nice install.
Well, you know, I mean, we got 4 hours on it now, and couldn't be happier. Still collecting data, but man, I tell you, the seat of the pants difference is night and day. It's just, it's like going from an old points ignition in a '57 Chevy to, you know, HEI when they came out back in the day. So big difference.
Cool. Very cool. Mike, you got anything else?
No, I'm done.
Okay. Anybody got any more questions? I think we can let these people retire for the evening, Mike.
I think we can. Everybody, I appreciate you coming out. This has been fun.
Thank you for putting it on.
Thank you, guys.
Thank you.
Thank you.
Take care. See you now.
Appreciate it. See you guys.
Yep. Bye.